Hello everyone, welcome back to the new interesting video of our channel. So in the previous video we have discussed about the method of resolution. The method of resolution is dividing the given force into horizontal and vertical component. Now horizontal and vertical components are required to find out the resultant. So this is a given force. Now we'll resolve only inclined forces. So this is the inclined force of magnitude F and the angle with the x-axis is equal to theta. To find the resolution, first we will draw a perpendicular from this point on the x-axis. Then this component becomes your horizontal component Fx and this component becomes your vertical component Fy. Now this component and the length of this component is similar. So we will consider this triangle for the resolution. So this is the given triangle. F is the hypotenuse, this base is equal to Fx and height of this triangle is equal to Fy and the included angle is theta. Now we will use the sign relation. Fy divided by F means sin theta is equal to opposite side upon the hypotenuse. So Fy divided by F. So Fy becomes F into sin theta. Same way, if we use cos relation, then cos theta is equal to opposite side upon hypotenuse. So it is Fx divided by F. So the value of Fx will be F into cos theta. So in this way, by using simple relations of sin theta and cos theta, we can calculate the values of Fx and Fy, F cos theta and F sin theta. Now about the sign. When we consider a horizontal force, it's pointed towards right side, then we consider it as a positive. If it points towards the left side, we consider it as a negative. In case of a vertical component, when it is pointed upward, we consider it as a positive. When it is downward, we will consider it as a negative. So in this case, Fx and Fy both are positive. Now we'll find the second case for the first quadrant only. Instead of taking this angle, we'll consider the second angle with the vertical axis. So this is the angle theta. Now we'll find out Fx and Fy. Okay, so this is the value of Fx, this is the value of Fy. So instead of considering this as a triangle, we'll draw one perpendicular from this point to the y-axis. So now this becomes your triangle. So this is the required triangle, this is the value of Fx and this is the value of Fy. So F is the hypotenuse, Fx is the base, Fy is the height and theta is the angle between the y-axis and the force. Now we'll write the sin theta. Sin theta is equal to opposite upon hypotenuse. So it is Fx divided by F. So your Fx value becomes Fx is equal to F sin theta. Now cos theta is equal to adjacent upon hypotenuse. Adjacent is Fy divided by F. So your Fy becomes F cos theta. So in this way we have calculated the value of Fx and Fy. Fx is equal to F sin theta. Fy is equal to F cos theta. Okay, so if you observe it carefully, in previous case here we have got the cos theta, it replaced by sin theta, and here there was sin theta, it replaced by cos theta. That is the only difference. Sin is same because this is towards right and this is towards upward direction. Now we'll check it for the second quadrant. So this is the second quadrant, this is the applied force F and the angle with the x-axis is equal to theta. Now we'll draw one perpendicular from this point to the x-axis. Now we'll consider this triangle. So in this triangle, this component becomes your horizontal component and this is your vertical component Fy. We'll plot the same triangle here with all other dimensions and the included angle theta. Now we'll find first thing sin theta. Sin theta is equal to opposite upon hypotenuse. So it is Fy divided by F. So your theta is shown here and Fy becomes F sin theta. Now we'll find out the cos theta, adjacent upon hypotenuse. So Fx divided by F. So Fx becomes F into cos theta. So in this way you can calculate the Fx and Fy value for the second quadrant. Now I'll put it here. Now see here, the same values are written here, but the only difference is here they have put minus sign. Why minus sign? Because Fx acts towards left side. It is pointed towards the left side, that's why it is negative. Fy is upward, so it is positive. method of resolution in the second quadrant considering second angle with the vertical axis. So this is the vertical axis, angle theta. So we'll draw a perpendicular here. So this is our triangle shown here, and fx is the horizontal component and fy is the vertical component for this possible combination. So we'll plot the same triangle here. F is the hypotenuse, fx is the base of this triangle, and fy is the height. So this is horizontal component and this is vertical component. This is the included angle theta. Now we'll write the sine relation for this triangle. Now for this theta, this is the opposite side, this is the hypotenuse. So sine theta is equal to opposite upon hypotenuse, so fx divided by f. So fx becomes f sine theta. For this angle, this is the adjacent side, so cos theta is equal to fy divided by f. So we have got fy is equal to f cos theta. So in this way we have calculated the values of fx and fy. We'll put it in the table. Fx is equal to f sine theta, fy is equal to f cos theta. Okay, now minus sign indicate it's pointed towards the left side and it is pointed towards the upside. Now we'll go to the third quadrant. So this is the applied force in the third quadrant. The magnitude is f and the included angle is theta. Now we'll first draw a perpendicular from this point to the x-axis. Now this is the triangle and this component is horizontal component and this is the vertical component, fx and fy. Plot the same triangle. Now the value of hypotenuse is f, this is base fx, height fy, included angle theta. Now find out the sine theta. For sine theta, this is the opposite side and this is the hypotenuse, so it is fy divided by f. So fy is equal to f sine theta. For this angle, this is the adjacent side and this is the hypotenuse, so fx divided by f. So fx is equal to f cos theta. Now put the values. So before putting the value, identify the sign. For horizontal component, it acts towards left side, so this is value is negative. For fy, it is downward, so downward force is negative. So we'll get the values of fx and fy, both are negative. Now in the third quadrant, we'll consider the second angle with the vertical axis. Now we'll draw a perpendicular from this point to the y-axis. So this is the required triangle. This is the value of fx and this is the value of fy. Now we'll plot the same triangle with this included angle theta, hypotenuse f, base fx, height fy and angle theta. Now we'll find the sine theta. For this theta, this is the opposite side, this is the hypotenuse, so it is fx divided by f. So fx is equal to f sine theta. For this angle, this is the adjacent side and this is the hypotenuse, so cos theta is equal to fy divided by f. So fy is equal to f cos theta. Now see, horizontal component is towards left, so it is negative. Fy component is downward, so it is negative. So we'll put minus sign at their respective places. Now think about the fourth quadrant. This is the force which applied in the fourth quadrant. Magnitude is f, angle with the horizontal is equal to theta. Now we'll draw a perpendicular from this point on the x-axis. So this is the included angle, the value of fx horizontal component, the value of fy vertical component. Now we'll plot the same triangle here. Show all other dimension, hypotenuse f, base fx, height fy, included angle theta. Now for this included angle, the opposite side is fy and the hypotenuse is f. So sine theta is equal to fy divided by f. So fy is equal to f sine theta. Same way for this theta, adjacent side is fx. So we can write cos theta is equal to fx divided by hypotenuse. So fx is equal to f cos theta. So in this way we have calculated the value of fy and fx for the fourth quadrant. Now think about the sign. Fx is towards right, so it is positive, but fy is downward, so it is minus, right? So we can write the values of fx as f cos theta and fy is equal to minus f sin theta. Okay, in the next case we will see the angle with the vertical. So we'll draw one line here, perpendicular line. Now fx value is this one and fy value is this one. Consider this triangle here. Hypotenuse is f, base is fx, height is fy and this is the included angle. Now for this angle, opposite side is fx and hypotenuse is f. So sin theta is equal to fx divided by f. So value of fx is equal to f sin theta. Now for this angle, adjacent side is fy. So cos theta is equal to fy divided by f. So fy is equal to f cos theta. Now think about the sign. This is towards right, so positive. This is downward, so negative. So fx is positive and fy is negative. Now we'll summarize. So for the first quadrant, the values of fx and fy for both the combinations of theta is shown here. You can observe that only change is cos is replaced by sin and sin is replaced by cos. This is the second quadrant. Angle with x and angle with y is shown over here. Then this is the third quadrant. Angle with x and vertical is shown here. Similar case with the fourth quadrant. So few observations we can note here. So fx and fy value, when the angle is with x axis is given, all other values are f cos theta, fx, and fy is f sin theta. It is common everywhere. So you can remember that fx is equal to f cos theta, fy is equal to f sin theta, all for all other cases. Now about the sign, we talk about fx. When it is towards right, its value is positive. Mean first and fourth quadrant, the value of fx is always positive. In case of second and third quadrant, it is pointed towards left side, that's why the negative sign comes. Then fy, when the fy is upward, for first and second quadrant its value is positive, and for third and the last quadrant, fourth quadrant, its value is minus because it is pointed towards downward direction. Now when we consider the angle with vertical axis, the condition slightly different. So for fx we got f sin theta and for fy we got f cos theta. Exactly opposite of the above case. In the above case, fx was f cos theta and fy was f sin theta. Now cos replaced by sin and sin replaced by cos in the equation. You can take a printout of this chart or you can take a screenshot and you can remember all other things for the fx and fy components in the respective quadrants. So it is very simple. You should have a knowledge of sin theta and cos theta and you should know the direction of the force. Then we can easily find out. Then we'll go to some special cases. For example, this force is not inclined, it is horizontal force. So for the horizontal force, the value of fx and fy will be fx is equal to magnitude of this force F. If it is 10 Newton, you should write 10 Newton. And for this horizontal force, there is no vertical component, that's why Fy is equal to 0. Then this is the second case of the horizontal force. It lie here. Its direction is towards left side. So value of Fx and Fy will be Fx is equal to force and its sign is minus because it is pointed towards left side. So this is minus F and value of vertical component is 0. Always remember, for horizontal component its vertical component will be 0 and Fx value will be equal to F. Don't write cos theta sin theta in that way. You can write Fx is equal to F and Fy is equal to 0. If the force is vertical, then what is the value of Fx and Fy? If you know this, you can write it in the comment box. So this is the value of F. So Fx and Fy. So Fx will be 0. For vertical forces, the horizontal component should be equal to 0 and Fy value will be equal to the magnitude of the force. Then this force is pointed downward. So Fx and Fy value for this force will be Fx will be 0 and Fy is equal to minus F. Minus sign indicate it pointed in the downward direction. For horizontal force, Fy component is 0 and for vertical force, Fx component is 0. Now we'll find out the resultant. Resultant is a single force which replaces all other forces and have the same effect. So it can be calculated by R is equal to square root of summation of Fx square plus summation of Fy square. Now summation of Fx is the addition of all the horizontal component present in the force system and Fy is the addition of all vertical component present in the system. When we solve the numericals, you will come to know how to find out summation of Fx and summation of Fy. Now we'll find out angle of resultant with x-axis. So theta is equal to tan inverse of summation of Fy divided by summation of Fx. So by this way we can calculate the angle theta. I hope you understood how to find the resolution for various forces for various quadrants, as well as you come to know how to find out the resultant and its angle with the x-axis. I hope you like this video. Thank you very much.